Okay. Now please let me know that sound quality, picture quality, everything is fine now. Yes. I think now everything is fine. Okay then. Now guys, voice Manoj, now it is okay. Now this is a IISC Bangalore previous year question series, GATE 2024, 2002, 2008 and 2016 guys. Okay. And welcome to the BYJU'S exam prep. This is Sanjay Rathi. Stay tuned with me and try to solve this question on your scribble pad. And you can use your virtual calculator also. And remember guys, I have to arrange two sessions for that, part 1 and part 2. In part 1 and in part 2, we will discuss questions from electronics and what electrical branch. And all questions are highly conceptual. So please try to solve all these questions. Okay, and subscribe our channel and join my Telegram channel so that you will get the link and PDF of this session. Okay, then this is my introduction. I am having 22 years of teaching experience, and during these 22 years, I have trained more than 1 lakh students for these competitive exams. And I have qualified and selected for engineering services exam. These are my ranks in ESE 2005, AIR 16 and ESE 2008, AIR 21. And guys, now notification for engineering services exam 2024 is out. So please go through that and fill the form accordingly. तो आप एलिजिबल हैं वो चेक कर लीजिए और सिंसियरली अपनी प्रिपरेशन स्टार्ट कर दीजिए फॉर इंजीनियरिंग सर्विसेज एग्जाम गाइस. ओके, एंड दीज आर माय सब्जेक्ट्स. नाउ this is my Telegram channel link, Electronics by Sanjay Rathi, for daily dose to improve the concept, for daily important questions, and daily I will upload one question and try to give the answer for that questions guys. And the PDF of this session and all my YouTube sessions will be uploaded on my this channel, that is Electronics by Sanjay Rathi. Okay, so you can join now. And if you have cleared the mains examination guys, we are going to conduct what mock interview for you. And remember, what is the range from 60 marks to what 160 marks out of 200 you can get marks in what UPSC interview. So what is the range from 60 to 160. तो आप देखो इतना इंप्रूव कर सकते हो. अगर आप इंप्रूव करना चाहते हैं देन गिव द मॉक इंटरव्यू, राइट, एंड देन वी विल प्रोवाइड यू द फीडबैक, वर्क ऑन इट, देन डेफिनेटली यू कैन इंक्रीज योर नंबर. ये आपके सिलेक्शन के लिए बहुत ज्यादा जरूरी है. ये लास्ट स्टेज है. ऑलरेडी यू हैव क्लियर्ड व्हाट प्री, देन मेंस, देन व्हाट फाइनली इंटरव्यू. तो डोंट टेक इट लाइटली. तो इफ यू हैव योर रिजल्ट्स देन यू कैन शेयर विद अस. देन नेक्स्ट थिंग, this is the first question guys from electronics branch, 1 mark question in 2016 EC 1 mark question. Then tell me, assume that the diode in the figure has V on 0.7 volt, that is the practical diode, but it is otherwise ideal. The magnitude of the current I2 in milliampere is equal to, what is the value of the I2, right? That is the question in 2016. Again, it is the conceptual question, only 1 mark question. How we can solve this? Then there may be two cases. Diode may be on or diode may be off, and minimum voltage required is what 0.7. What is the voltage required? 0.7. Then first of all you can assume let the diode is off. Let the diode is off, because there are two cases, diode may be on, may be off. Let the diode is off. If this is off, it will act as open circuit. You can make it what open circuit. Okay, there is no diode. So what is the drop across the resistor? According to voltage division rule, drop will become, drop across the resistor VR1, 2 divided by 2 plus 6 into 2, and that is equal to 2 into 2 divided by 8, that is 1 by 2. And that is nothing but 0.5 volt. Okay, so the drop across this resistor is 0.5 volt, and what is the required voltage? 0.7 volt. What is the required voltage across the diode? 0.7 volt. Means the diode is what? Off. When the diode is off, means our assumptions is correct. Diode is initially off because we are having only the 0.5 volt here. and remaining 1.5 volt is here. That's why the diode is off. And what will be the current? You can find 2 divided by 8. 2 divided by 8, that is the 0.25 milliampere, because the resistors in kilo ohm. Resistors are in kilo ohm. Okay, Sagar Joshi, your answer is correct, 0.25. Next question, without any delay, quickly we will solve. And then, okay, share the link of this session so that the student will join. Now, next question. Now, this is a very important one, guys, on capacitor filter. The figure shows a half-wave rectifier. This is a half-wave rectifier with a 475 microfarad filter. That is in 2016 ECE 2 marks question. We can expect similar question in electrical branch. So, how many students from electrical? If you are from electrical branch, guys, so subscribe the channel. And second thing, try to solve the question from what? Electronics branch. And electronics students solve questions from electrical branch, because analog is common subject. Previous year question. Okay. So this is the question. The figure shows a half-wave rectifier with a 475 microfarad filter capacitor. This is the 475 microfarad. Then the load draws a constant current I0, 1 ampere from the rectifier. 1 ampere. This is the 1 ampere current from the rectifier. This is the any load. This is the load resistance. And what is the load current? 1 ampere. The figure also shows the input voltage Vi, the output voltage Vc. This is the input voltage Vi, triangular wave. This time it is not sinusoidal, it is triangular wave. And that is the voltage across the capacitor Vc. And the peak to peak voltage ripple U on Vc. That is the peak to peak voltage ripple on U on what? Vc. This is given. This is given. Right? Where is the ripple voltage? This one. Peak to peak means from this point to this point. Okay. The input voltage Vi is a triangular wave with an amplitude of 10 volt and a period of 1 millisecond. What is the time period of that? 1 millisecond. And what is the peak value? 10 volt. The value of the ripple U is, what is the peak to peak value of the ripple voltage? Now, this is the standard question on capacitor filter, very lengthy question, but the answer is what? Very easy. Now, remember, we are familiar with this diagram. We are having one capacitor here and we are having one resistor, load resistor here, RL. And this is called IL, or we are finding the DC current. Or when the capacitor value of a capacitor is very high, that is the 475 microfarad. This is the value of the capacitor. Then this period from this point to this point, watch this diagram. From this point to this point, capacitor will remain off, right? And then in very short duration, the capacitor will charge, guys. So this is called off period, where the diode is off and the capacitor will discharge. This is the voltage across the capacitor, it will discharge. And during this period, the capacitor will charge. This is called on. So T on means diode is on, T off means diode is what? Off. Therefore, the capacitor will discharge. Therefore, here the capacitor will charge. Now, we are having the constant current. So, what is the charging or discharging? So, during T off, watch this formula. During T off, the capacitor will discharge. What is the change in the voltage? What is the change in the charge? The capacitor will discharge by amount that is given by I into time. That is the I into T off. I into T off. So, what is the change in the voltage? The change in the voltage is given by, that is called U. That is the ripple voltage, peak to peak value of the ripple voltage. Change in the charge upon C. That is I T off upon C. And for best filter, T off is very greater than T on. For best filter, T off is very greater than T on. And for half-wave rectifier, T on plus T off is nothing but T. So we can say T off is nearly equal to what? T. That is 1 by F. What is the time period of the, this is the time. Why I am saying that from this peak to this peak, this is the time period. T. And T on plus T off, it is nothing but T. T is given in the question and T off is very high. So what is the T is given in the question? 1 millisecond. And what is the value of the current? 1 ampere. This is the value of the current that is provided by what? VC. So directly you can use this formula, and then I 1 ampere, 1 milliampere 10 to the power minus 3 upon 475 into 10 raised to power minus 6, 475 microfarad. That is the value of the capacitor. Okay, please everyone calculate the value and give me the answer. 475 microfarad. Now you can find around 2.105. 2.105 volt. Okay. Now some students are familiar with, sir, I am comfortable with this formula, VR ripple voltage peak to peak. That formula, Vm upon FCRL. Vm upon FCRL. Yes, this is also correct. You can directly use this formula. What is the Vm upon RL? Current. What is the 1 by F? Time period. Upon C, same thing. What is the current? Vm by RL is the load current. Already it is given 1 milliampere. 1 ampere. What is the T? 1 milli. What is the C? 475 into 10 raised to power minus 6 microfarad, that is converted. And again you can find the 2.105 volt. 2.105 volt. Any doubts, Sagar, Manoj, anyone? Then that is the answer for this question. Okay, then next one. So this is the answer, 2.105. Now next question. So already I have derived this formula in my class. I think 2 days back in paid classes I have derived the complete formula. What is the ripple voltage across the capacitor, and that is in IISC Bangalore. That was the question. Okay. Then the diodes D1 and D2. D1 and D2 in the figure are ideal and the capacitors are identical. The product RC is very, very large. This product R and C, the time constant is very large compared to the time period of the AC voltage. Means RC is very, very greater than time period of the AC signal. Assuming that the diodes do not break down in the reverse bias, the output voltage V0 at steady state is. What is the output voltage V0? Well, this question is very easy. Everyone try to give me the answer. Then watch this. This is 10 sin omega t. Okay. Now, what will happen when this is plus, this is minus? Both the diodes will on. When both the diodes will on, it will act as short circuit. So what is the maximum value? 10 volt. So this capacitor, because this is the direction of the current, this capacitor will charge by 10 volt. Similarly, this is the direction of the current. So this capacitor will charge by 10 volt. Okay, once it will charge by the 10 volts, the time constant is very high. That's why the capacitor will not discharge. Now you can remove the circuit, focus on this. This is R. This is plus minus 10. This is minus plus 10. So what is the total voltage? Plus 10 minus 10, that will become 0. That will become 0 volt. So actually we want to design what? Voltage doubler. But there is a mistake in what? Connection. And that's why we are getting the 0 volt answer. Yes, Amrita, your answer is correct. Sagar, your answer is correct. So this is a 0 volt. So it is not a perfect voltage doubler. There should be the change in the polarity of what? Diodes. You have to change the polarity of the diode, then we can get the exact answer. Okay. The next question, next one. So this is the 0 volt. So answer is 0. Now, GATE 2002 ECE 2 mark question. Okay, again on the diode. देखो, remember electrical and electronics branch, from this paper you can get the idea that rectifier is important, diodes are very very important, voltage regulator is important, operational amplifier is important, and we are getting the different type of questions. So in first part I will discuss, and in second part again I will discuss what more important questions. So please attend both the parts and download the PDF of these sessions and go through that. That will boost your confidence. For example, rectifier with filters, and then again what symmetry triggers. We are having the different types of questions in 2002, 2008 and 2016. Yes, Amrita Khanna. Now your statement. Now, this is a question on voltage regulator. Zener diode regulator in the figure is to be designed to meet the specification. IL 10 milliampere fixed means what about the RL? RL is fixed. How we can say RL is fixed? Because IL is fixed 10 milliampere. Zener diode. V0 10 volt means what should be the breakdown voltage of the Zener diode? 10 volt. Because in Zener diode V0 is equal to Vz. So Vz is 10 volt. It is given in the question. V in varies from 30 to 50 volt. It is variable. 30 to 50 volt. The Zener diode has Vz10, Izk, knee current 1 milliampere. For satisfactory operation, what should be the value of R? Very basic question on voltage regulator by using Zener diode. Now watch this. What is the answer for this question? First of all, for full range of Vi, Zener diode should remain in breakdown region. RL is not a variable. So for full range of Vi, Zener diode should be remain in breakdown, means Iz minimum. Minimum current through the Zener diode should be greater than what Izk. Should be greater than knee current. Otherwise, it will not remain in breakdown region. Then how we can find the minimum current through the Zener diode? This is called I. This is IL. What is the Iz? You can apply the KCL at this point. What is the incoming current? I. What are the outgoing current? Iz plus IL. What is the Iz? Iz is I minus IL. IL is fixed. When we will get the minimum current? When I is minimum. What is the Iz minimum? I minimum minus IL. And this IL is fixed. I minimum minus IL. Otherwise, we will check what IL maximum. If suppose the RL is variable, then that is the formula. I minimum and IL maximum. And that's why the difference will remain minimum. But in this question, IL is fixed. And I minimum, how we can find the I minimum? Vi minimum minus Vz. This is the Vi minimum minus Vz. Because this voltage is Vz, that is nothing but 10 volt. Why we are taking the minimum? When we are giving the minimum value here, you will get minimum value of this current. Vi minimum minus Vz upon R. IL is fixed at 10 milliampere. This current should be greater than or equal to Izk. And what is the Izk? 1 milliampere. Now you can put the V minimum 30, 10 upon R minus 10 should be greater than or equal to 1. Then it is 20 by R should be greater than or equal to 11. So what is the R? R should be less than or equal to 20 by 11 kilo. 20 by 11 kilo ohm. Now find the value. What is the 20 by 11 kilo ohm and then convert it into what? Ohm. So R should be less than this value. I think you will get 1818 ohm. 1818 ohm. This R should be less than 1818 ohm for satisfactory operation of this circuit. Then R should be less than 1800 ohm. This is the correct answer. This is not the correct answer. This is not the correct answer. This is not the correct answer. A is the correct one. That is the answer for this question. Zener diode means we are having the very, very important formula. This one. This is a very, very important one. So please note this formula. And this is the minimum current, and that current should be greater than what? Izk. If any question Izk is not mentioned, then ideally you can take it what? 0. Right? Knee current, minimum Zener diode current for breakdown. If it is not mentioned, then you can take it what? 0. That is the answer. Now, So again, this is a good question. A option, MCQ. Next one. Now tell me what is the answer for this question. Very, very easy. Again, we are having the multiple diodes, one Zener diode, one normal, two normal diodes, right? And what is written here? In the following limiter circuit, that is limiter means clipper circuit, an input voltage 10 sine 100 pi volt, 100 pi t volt, there will be 30, is applied. Assume that the diode drops is 0.7 volt. When it is forward bias, the general breakdown voltage is 6.8 volt, that is visible. Maximum and minimum value of the output voltage respectively are. What is the maximum value and what is the minimum value? Normally, that is the normal question in clipper. In clipper, we are getting the maximum minimum or what transfer curve. What is the maximum and minimum value? So what is the maximum and minimum value of Vi? 10 and minus 10. So 10 and minus 10, then if you want to find the maximum value, put here plus 10. This is plus 10 Vi. Because of this plus 10, what will happen? This diode, because it is the highest battery, definitely this D2 is off and the current will flow like this. When the current will flow like this, this is forward bias and that is breakdown because we are having the sufficient voltage 6.8 and therefore you can take this diode as off, make it off. This is off. Okay. Then 0.7 plus 6.8, what is the V0? 7.5 volt. This is the maximum value of the output voltage. And that diode is reverse bias. 10 here, 7.5 here, 2.5 voltage is across the resistor. It will limit the output. What is the maximum value of the input? 10. But what is the maximum value of the output? Only 7.5. It will limit the output. So the student have given the 7.5 and 0.7. So that is the first answer. Second one, when we are taking a reverse bias, this is minus, this is plus, and what is the minimum value? Minus 10. So this is the minus 10. When we are getting the minus 10, this is not a breakdown diode, it is a normal diode, and that's why it will not allow the current. Definitely it will not allow the current. The current will flow like this. When the current will flow like this diode is forward bias. This is plus, this is minus. This is 0.7. So what is the V0? V0 is minus 0.7. V0 is minus 0.7 and this path will act as what? Open circuit. So you can remove this part. You can remove this part. That will not allow the current. So this diode is forward bias, but it is in opposite direction. That's why minus 0.7. Yes, I think you have given the minus value. So which answer is correct? Out of this two, C. C is the correct one. C is the correct answer. Okay. So it is a 1 mark question only, electronics. So quickly you have to solve, right? Time management, accuracy, speed. So it is possible by giving what? Mock test. Are you giving mock test, everyone? Are you giving mock test? No, then remember in the same description you will get the link. You can download our app, BYJU'S Exam Prep. Free mock test is available. Try to give that mock test and papers are available. Previous year question papers are available on our app. Try to give those previous year question paper. Okay. So you can start from what 2003, 2004 and up to what 2023. So day by day try to give the try to solve the previous year question as well as try to give what? Mock test. Then watch this. This is the 7.5 and minus 0.7. The next question. Now, this is the question on BJT. In 2002 EC 1 mark question. If the transistor in the figure is in saturation, then guys, what is the saturation? Okay. IC is always equal to beta DC IB. So this is the situation when it is in active region. IC is always equal to minus beta DC IB. That is the situation in case of what? Not, that is not possible. Minus, how is it possible? Minus, what is the direction of the current? IB, IC, this is the NPN transistor. So IC is equal to beta IB. That will be the case in active region. So this is in active region. Active. This is not possible. Now, IC is greater than or equal to beta DC IB, or IC is less than or equal to beta DC IB. Tell me which answer is correct out of C and D. Which answer is correct? Give me answer in comments box. Then watch this. Okay. Now, this is the graph. Right. This is IB. This is IC. This is the saturated voltage IC set. This region is called active region. Right? And up to this point, this will follow this equation. What is this? IC is equal to beta IB. And therefore, what is the slope of this line? IC. What is the slope of this line? Beta. And after that, it is saturated. Then this is called IB minimum. This is the IB minimum for which transistor will be in saturation. So this is the minimum value of the base current required for what? Saturation. Once the IB greater than that, we are increasing the IB above IB minimum. Above IB minimum, but the current will not change. It will remain what? Beta times of IB minimum. This is the value of the IC set exactly at the boundary of active and saturation region. Guys, suppose you are here. So IB is greater than IB minimum. So when it is multiplied by the beta DIB, since the IB is greater than IB minimum, that's why this term is greater than what? Beta times of IB minimum. And therefore this term is greater than what? IC set. Or we can say IC set is less than what? Beta times of IB minimum in case of saturation. So less, so one student have written, it may be equal or less than that. So that is which answer is correct? D. Equal to beta DIB. Okay, that is the case. This is the possible. So remember this graph, you can solve the question on this particular graph. Okay. So in active region, it will always follow IC is equal to beta IB. Then next question. Okay, the Ebers-Moll model of BJT is valid. Guys, I want to take one session on that Ebers-Moll model, right? So where I will explain, because this is important. And Ebers-Moll model, as you know, according to this Ebers-Moll model, it is not possible to design a transistor by connecting two diodes back to back. If suppose you are going to connect two diodes back to back and we are assuming that it is a PNP transistor, no, it is not possible. It is not possible to design the transistor by connecting two diodes back to back. That is according to Ebers-Moll model. And remember, Ebers-Moll model of BJT is valid for all regions. All. This is only in active region, only in active and saturation mode, only in active and cutoff mode, inactive, saturation and cutoff modes. That is valid for all modes. Inverse active mode, again we can draw the diagram for that. Okay, so this is about the Ebers-Moll model. So these days we are not getting question, but okay. Then it is in 2016 EC, last time, that was paper conducted by IISc Bangalore. This is the answer. Now this one, This is a question on what? Current mirror circuit. Current mirror circuit, and 2-mark question in 2008. For the circuit shown in the following figure, transistors M1 and M2 are identical. Identical means what? K, mu n CUX, W by L, that is what? Aspect ratio, all are same, are identical. Assume that M2 is in saturation, okay, and the output is unloaded. Output means we are not connecting any RL here, right? Then current Ix is related to I bias. I bias means this is called DC current, biasing current, I DC current. The current or reference current will flow like this. Now remember, from this point to this point, both the transistors have the same VGS, right? Both the transistors have the same value of VGS. If both are having the same value of VGS, means what? This is already written, M2 is in saturation. This is in saturation. And when the gate terminal is sorted to drain terminal, this is the gate is sorted to drain, then definitely M1 is also in saturation. Because when the gate is sorted to drain, VGD or VGS is equal to what? VDS. Both are equal because this is sorted. So VG, since VG is equal to VD, so we can say VDS is greater than what? VGS minus VT. So that is for first, and that's why it is in saturation. Already it is in saturation. VGS are same. Means what? This current Ix is equal to what? I bias. What is the gate current? 0. Gate current enter into this is 0. That's why the current in this branch is 0. So I bias is equal to what? Ix, or Ix is equal to I bias. That is the current mirror circuit. हाँ, आ सकता है करंट मिरर से भी आ सकता है, क्यों नहीं? ओ नो, कहाँ गए पार्ट? So that is in syllabus, they can give any type of questions. Suppose JFAT is not in syllabus, that's why we are not expecting question from JFAT. But we can expect question from current mirror by using BJT. Which answer is correct? B. B is the correct answer for this particular question, guys. Okay. Okay then. The next one. This was the question in 2016 EC 1 mark. That is the current mirror circuit, but here we are having the R2 register and this is R1, right? Now register R1 in the circuit below has been adjusted so that I1 is equal to 1 milliampere. This is the 1 milliampere current. The bipolar transistor Q1 and Q2 are perfectly matched, means properties are same, beta same, everything is same, and have very high current gain, but beta is very, very large, so that their base currents are negligible. The supply voltage VCC is 6 volt. This is 1 milliampere, and what is the base current? 0, just like a previous question. Beta is very large. What about the 1 milliampere? This is the 1 milliampere current. 1 milliampere current, and what is the current in this branch? 0. VCC is 6 volt. So that their base currents are negligible. The supply voltage is 6 volt. The thermal voltage is KT by Q 26 millivolt. The value of R2, for which I2 is 100 microampere. You have to find the value of the R2, for which I2 is equal to 100 microampere. 100 microampere means what? 0.1 milliampere. 0.1 milliampere. And this is how you have to find the value of R2 here. Okay. Now, these are the two transistors, both are identical, but this current is not equal to that current. Why? Because we are having the resistor here and you have to find the value of the resistor. Now watch this. That is the property of the transistor. Watch this question. Here, this voltage is VBE1 and this voltage is VBE2 and this voltage is like I2 into R2. This is what Vx, I2 into R2. You have to find the Vx, then you can find the value of the R2, because Vx upon I2 will give you the R2. I2 is given 0.1 milliampere. Then these two voltages are equal. So what is the VBE1 is equal to? VBE1 is equal to VBE2 plus Vx. Why these are equal? Because they are in parallel. So they are in parallel. That's why this is the equation number 2. So what is the Vx here? VBE1 minus VBE2. That is the equation number 2. Now we have to find the VBE1 minus VBE2. Now we have the current through this transistor. We have the current through this transistor. What is the equation of the current through the transistor? That is given by IC nearly equal to I, that is given by reverse saturation current through the transistor, e raised to power VBE upon eta is always 1 for the transistor, VT minus 1. But what we are doing when it is forward bias and when the current, this current is 1 milliampere or what 100 microampere is very large, then you can neglect this term. So what is the, we can say what is the IE1? IE1 or IC1 is equal to I naught e raised to power VBE1 upon VT. Similarly, what is the IE2 or IC2 is equal to I naught e raised to power VBE2 upon VT. This is the equation number 3. This is the equation number 4. Divide 3 and 4. When we are dividing 3 and 4, remember this is the, already we have the value. So directly you can put the value also. Or you can write IC1 upon IC2 is equal to e raised to power VB1 minus VB2 upon VT. And what is the IC1 upon IC2? This is the 1 milliampere and this is the 0.1 milliampere. That's why you will get 1 milliampere divided by 0.1 milliampere, that is nothing but 10, is equal to e raised to power VBE1 minus VBE2 upon VT. Now you can take this is the e raised to power VBE1 minus VBE2 upon VT is equal to 10. Take log VBE1 minus VBE2 is equal to log 10 into what? VT. Log 10 into VT. So what is the VT here? What is the question in question? VT, KT by Q. VT is volt, thermal voltage, that is given by KT by Q, 26 millivolt. Now this is 26 millivolt. Okay, into log 10, and this is nothing but Vx. This is nothing but Vx. And what is the R2? Vx upon I2, that is nothing but 26 log of 10. This is in millivolt, because 26 it is in millivolt, upon I2, that is 0.1 milli cancel. You will get answer in what? Ohm. You will get answer in ohm. Tell me, calculate it. This is the formula. What is the R2 in ohm? It is given. So R2 in ohm you can find. Use your calculator and find the answer. So remember, this is millivolt, this is milli cancel, and you can find the answer in ohm. So guys, why we are connecting this resistor? We are connecting this resistor to reduce this current 10 times. If this resistor is not present here, then this I2 will be exactly equal to what? I1. I2 will be exactly equal to I1, then it is called current mirror circuit. But when we are connecting the resistor, I2 is 10 times less by I1, okay, because of this resistor, okay. So and normally what in our syllabus, that is a Widlar's current source, Widlar, Wilson, but in GATE exam normally they are not mentioning the name of that circuit. Simply they will give the circuit and try to solve the questions only. So no need to mug up. Yes or no? Widlar or Wilson, you heard about these names. You can find the answer. Now next question. Next one. So that is a question on current mirror circuit. Okay, now this is a very important topic. RC coupled amplifier. Resistor capacitor coupled amplifier. Common emitter configuration, 180-degree phase shift. Normally we are getting question on this. This is a very important one. In the following transistor circuit, VBE is equal to 0.7 volt and RE is equal to 25 divided by IE. This is 25 millivolt divided by IE. This is the value of small RE. And beta and all the capacitance are very large. The value of DC current IE. Tell me what is the value of the DC current IE? What is the value of the DC current IE, guys? Okay, if you enjoying the session, like the session, guys, and subscribe the channel and download the app and try to solve the questions from mock test. Try to solve the questions from previous year question booklet. All papers are available there, and explore that app. Okay. Then in this question for DC analysis, always remember all capacitor will act as open circuit for DC. All capacitor will act as open circuit for DC. This capacitor will act as open circuit. This capacitor will act as open circuit. To remove this pure circuit, 3 kilo ohm is removed. Okay, this is removed. This capacitor will act as open circuit. This is removed. Now, this is the circuit. Now, you can apply KVL here. First of all, voltage division rule. According to voltage division rule, what is the voltage at this point? You can find the voltage at this point. This is called Thevenin's across this base. So what is the VTH? 10 divided by 10 plus 20 into 9 volt. This is the VCC. R2 upon R1 plus R2 into VCC, that will become 3 volt. Now what is given? Beta. Beta is very large. When the beta is very large, it is not given. This is written here, beta. When the beta is large, you can neglect the base current. Therefore, no need to find what? RTH. Just we are wasting our time to find the RTH, because there will be no drop across RTH. IB is 0. So what is this? VTH 3 volt. No need to find the RTH. This voltage is VB 0.7 volt and this is the IE, and RE it is given as 2.3 kilo ohm. Write down the KVL. So this is minus 3 plus 0.7 plus IE into RE is equal to 0. What is the IE is equal to? 3 minus 0.7 divided by RE. 3 minus 0.7 divided by RE, that is the 2.3 divided by 2.3. 2.3 divided by 2.3, 1 milliampere. 1 milliampere is the answer. Very simple question. 1 milliampere. Now, once you will get the 1 milliampere, what is the value of the small RE? This is called dynamic or incremental resistance. 25 millivolt upon 1 milliampere. Milli cancel and value is 25 volt. 25 ohm, not volt, 25 ohm. This is the value of small RE. Right, so that is the first question. This was the linked question, means total 4 marks question. Total 4 marks question in 2008. What is the next one? In the following transistor, VB capacitance is very large. Same question. Mid-band voltage gain of the amplifier. Mid-band voltage gain. You have to find the mid-band voltage gain. Now, this is the answer, minus 180, minus 120, minus 90, minus 60. Yes, it is minus because it is a common emitter configuration. And for common emitter configuration, what is the phase shift? Phase shift is 180 degree. And that's why the answer will be negative. Then how we can use the RE model for this question? RE model for this question. Watch this. Now, first, this is the diagram. For AC analysis, it is given in the question, all the capacitors are very large. This capacitor will act as short circuit. This capacitor will act as short circuit. This is the VI. This is the base terminal. This capacitor will act as short circuit. When this capacitor will act as short circuit, it will short circuit the 2.3 kilo ohm, and emitter is directly connected to ground. And for AC analysis, this VCC will tends to 0, means this is connected to ground. This point is also connected to ground. Then how we can use the RE model? Remember, this is the RE model, alpha I. This is RE. This is collector terminal, this is emitter terminal, and that is the base terminal. This is called RE model or T model. When the beta is very, very large, alpha is 1. Beta is very, very large, it is given in the question, so alpha is 1, and that's why you can directly write I. Now, watch this. First, emitter is connected to ground. You can make a common ground here. This is a common ground here. Okay. Second thing, 20 kilo ohm and 10 kilo ohm are in parallel. It is connected to base. 20 parallel with 10. Now here, it is VI is connected here. This is VI. 20 and 10 are in parallel. From collector to VCC, because it is ground, 3 kilo ohm is connected. Then from collector to ground, 3 kilo ohm. This is also connected from collector to ground. That's why it is also in parallel. And from collector terminal, we are getting the output with respect to ground. This is the V0, and with respect to ground, this is the 3 kilo ohm. And 3 kilo ohm are in parallel. That's why RL will become, effective RL will become 1.15 kilo ohm. 1.5 kilo ohm means 1500 ohm. Now here it is alpha I. So what is the current in opposite direction? Minus alpha I. Now watch this diagram, because there is no RS. So this is VI. This is also VI. Because it is connected in parallel. And what is the base current? 0. Same current. Alpha is 1. So this is IE. IE will flow through this. Emitter current will flow because it is emitter terminal, and base current is 0. So same current will flow here. Alpha is 1 because beta is very large. Now from this you can say VI is nothing but IE into RE. And what is the V0 is equal to 1500 ohm into what? Minus alpha I. Then you can write what is the V0 by VI minus alpha I into RL upon IE into RE. IE cancel, alpha is nearly equal to 1. What is the gain? RL by RE. Standard formula, minus RL by RE. Where what is the RL? 3 kilo ohm parallel with 3 kilo ohm. Effective RL, or sometimes it is called RL dash. Because normally we are saying this is RL, this is RC. So what is the RL dash? RL dash is nothing but RL parallel with RC. So this is the 1500 ohm. So what is the answer? Answer will become, remember direct formula, RL dash upon RE minus 1500 upon 25, that is minus 60. Mid-band voltage gain. Mid-band voltage gain. Okay. Amarnath Khanna, it is clear. So this is the case. If RE model is given, why we are taking the GM? GM is nothing but 1 by RE. GM is nothing but equivalent to what? 1 by RE. Again you will get the same answer. Now this one, this is the RE model. Directly you can apply the RE model here. Now next question, next one. If RS रहता ना अमरनाथ तो लंबा हो. That question, what you have to make the model and you have to use the voltage division rule in that case. Oh, RE, then if RE is getting, then there is another simple change. You have to use what model here, right? If RE is present, no problem. If RE is not bypassed, then simply made a model like this. Alpha I. This is a small RE. Now what is connected? Capital RE. This is ground, right? This is base. What is connected here? R1 parallel with R2 with respect to ground. What is connected here? VI. And now from collector to ground, two resistors are connected. And what is the value of RE? It is not bypassed, 2.3 kilo ohm. And what is this? Only 25 ohm. It is 2300 ohm. It is negligible. Now you can find, this is the 3 kilo ohm, 3 kilo ohm. So what is this? 1.5k, or this is the 1500 ohm. Now tell me, what is the V naught by VI, everyone? You can say minus alpha IE into RL dash upon IE. The same current will flow here, IE. You can write the VI is equal to IE into RE plus RE. This IE cancel, and standard answer is minus alpha RL dash upon small RE plus capital RE. So you can put the value of small RE, you can put the value of the capital RE, you can put the alpha is equal to 1. So what is the answer? 1500 divided by RE. What is the value of the RE? 25 ohm. Plus capital RE 2300 ohm. Find the value. What we are doing for approximation, we are neglecting the small RE. When we are neglecting the small RE, what is the approximate answer? Alpha we are taking 1, it will become RL dash. What is the RL dash? RC parallel with RL upon capital RE. When it is not bypassed, it is called approximate gain. Otherwise you can get the exact one. Is it clear? Is it clear, everyone? Yes. This is standard answer. Directly you can use. If it is not bypassed, then yes. Otherwise, no need to mug up, draw the model, connect it. Always remember, everyone remember, this is a model. Collector, base, and this is emitter. Transistor is replaced by this, and now connect extra components. And find, apply the network. Okay, then next question. If you want more detail, then please suggest me on my Telegram channel, that is Electronics by Sanjay Rathi. Please note the time, note the topic. Sir, I want session on this topic. If you find any difficulty on this, any topic, then please suggest me on my Telegram channel. Sir, I want session on this topic. I will arrange session. Okay then. Which one of the following statement is correct about an AC coupled common emitter amplifier? Again, that was the AC coupled common emitter amplifier operating in the mid-band region. So suppose there are three regions: low frequency region, mid-band frequency region, and what? High frequency region. So again, this is the question on mid-band. My dear friend, in mid-band region, the device parasitic capacitance behave like open circuit, whereas coupling and bypass capacitor behave like short circuit. The device parasitic capacitance, coupling capacitance, and bypass capacitance all behave like open circuit. Parasitic capacitance, coupling, and bypass behave like short circuit. The device parasitic capacitance behaves like short. coupling and bypass behaves like open circuit. Here are 4 options. Now, what is the answer for this one? Watch this. First of all, this is BJT. For example, it is BJT. Now, here we are having RE. This is bypass. This is emitter terminal. Now here we are having the coupling capacitor CC1. Here we are having another coupling capacitor that is called CC2. Here we are getting the output. Here we are giving the input. Okay, like this is the base terminal. This is emitter and that is collector terminal. Now guys, base and emitter junction is forward bias. So when the base and emitter junction is forward bias, from this point to this point, we are having one capacitor that is called diffusion capacitance. Internal, it is not visible. It is not visible, it is internal capacitance, diffusion. Because that junction is forward bias. At the same time, base and collector junction is reverse bias. So we are having one capacitor that is called transition capacitance. And this is the BJT. Just I have given what tentative diagram BJT. Now watch this. What is the ideal condition? We want this capacitor should pass the signal. Otherwise, signal will not amplify. So this should act as what? Short circuit. Coupling capacitor should act as what? A short circuit. So this capacitor will act as short circuit. Then it will allow the signal, and this signal should pass through the BJT. When this signal should pass through the BJT, then this should act as open circuit. This should act as open circuit, otherwise it will bypass through this. Then this signal will pass through the BJT. Now you will get the amplified signal here. We want the amplified signal should reach to what? RL. Therefore, it should act as what? Short circuit. This is the ideal condition. Then guys, RE. RE will provide the negative feedback. And because of the negative feedback, the gain will reduce. So what is the ideal condition? We want to bypass this RE. That's why we are connecting the bypass capacitor. So ideally it should act as what? Short circuit. So all the external capacitors should act as short circuit. All the internal or parasitic capacitors should act as what? Open circuit. And that is the diagram at mid-band frequency. So number of students are confused with the mid-band frequency. Then remember, complete conclusion here that we are having, this is the frequency response curve. We are having, this is the frequency response curve, guys. This is A naught. This is A naught by root 2. And that is the mod of gain, and that is the frequency. So this frequency range is called mid frequency range, guys. From this point to this point. That is asked in the question, what is the mid frequency? This is called low frequency gain. And that is called high frequency region. High frequency region. This is the low frequency region. Here the gain will fall because of the coupling capacitor. Bypass capacitor. Here the gain will fall because of the diffusion transition wiring capacitance or parasitic capacitance. So that is the case. Now which answer is correct? And in mid band, these all capacitor will act as short circuit and these all capacitor will act as open circuit. The device parasitic capacitance, coupling and bypass capacitance behave like open circuit. Wrong. Parasitic capacitance behave like open circuit, whereas coupling bypass capacitor behave like short circuit. Which answer is correct? A is the correct answer. It is a 2-mark question in 2016. 2-mark question from RC coupled amplifier. Okay, this is a theoretical question. And remember these 2 diagrams. If you want the PDF of all these, then join my Telegram channel, that is Electronics by Sanjay Rathi, or you can also join that Telegram BYJU'S exam prep here. This is link is given. Okay, done. Next. Now that is the question, guys. This is the question on what FET. But what is the FET? This is not in syllabus. So that is, if it is not in syllabus, but remember, AV of the amplifier, it is asked, what is given, what is provided in the question, that is more important. ID it is given, and then guys we have to find the GM, C1, C2, C3, very very large. But remember, you can leave this type of questions. Why? Because it is not in syllabus. JFET, junction field effect transistor, is not in syllabus. Simply leave it. Don't waste your time, right? Again, we have more questions. For example, that is the question. VP, pinch off voltage, and so on. When you are solving the previous year question, because we have limited time, so don't waste your time if it is not in syllabus. Again, that is the question on JFET. No doubt, it is for engineering services exam, but not for GATE examination. For engineering services, I will give the solution for this. It is a very, very conceptual question. We can expect question from this in ES, right? Because JFET is not mentioned in syllabus of GATE exam. So that is, you can leave it. So don't waste your time. Now, this one. This is the question on MOSFET. This is the metal oxide semiconductor field effect transistor. This is the symbol. Insulated gate field effect transistor. Yes, that is in syllabus. Two identical NMOS transistor M1 and M2. Two identical NMOS transistor M1 and M2 are connected as shown below. V bias is chosen so that both the transistors are in saturation. The equivalent GM of the pair is defined to be D out by DI out by dVi, transconductance. At constant V out, the equivalent GM of the pair is. It is a standard circuit. What is the name of this circuit? Here, watch this. We are giving the input to this one, and we are getting the output from this drain, and we are giving input to the gate, and that's why it is a common source. Then we are giving the input to the source, we are getting the output from the drain. This is the common gate. So it is the common source followed by the common gate. Common source followed by the common gate. And this is the cascade amplifier. Right? Or in cascade amplifier, we are having the different types of combination. Common source is equivalent to what? Common emitter, and common gate is equivalent to common base in BJT. So common emitter followed by common base. Sometimes we are using the common source, but second one is replaced by the common base. That is another pair for cascade. Sometimes it will remain common emitter, but here we are using the common gate. That is another combination. Cascading. Right? So common emitter followed by common base, common source followed by common base, common emitter followed by common gate, or common source followed by common gate. These both are FET, both are BJT, FET, BJT, BJT, FET. These all are called cascade amplifier. Right? Up when we are taking, right, to V out, so what is this? Sum of the individual GM of the transistor, the product of the individual GM of the transistor nearly equal to the GM of the M1 nearly equal to GM by G0 of the M2. Just remember, in this question, if suppose you are saying that it is the product of that, it is not possible. Why it is not possible? Because if you are saying that overall GM is the product of these two. So this is mho, and the product of these two will become mho square. That is not correct. That is not correct. Mho is equal to what? Mho square. That is not correct, guys. So it is dimensionally not correct. So what is the gain here? Always remember, first of all, this is the case where input is converted into current. Here we are giving the input, this is connected into the first current, and then second stage will simply pass. So here we are having the current gain AI2, and here we are getting the AI2. So what is the I naught 2 by I VI? This is the overall GM. I naught 2 by VI, that is the overall GM. We can write like this: I naught 2 upon I naught 1 into I naught 1 upon what? VI. So I naught 2 upon I naught 1 is the current gain of the second stage multiplied with GM1. This is I naught 1 upon VI is nothing but GM1. So that is the actual answer. AI2 of the second stage and into what? GM1. And what is the AI2 of the second stage? So second stage is common gate. Second stage is common gate. And therefore, the current enter is what? Same current enter through this terminal and same current will leaving this two terminal because the gate current is 0. So what is the current gain for the common gate? 1. You can write 1 here into GM1. That's why answer is what? GM1, transconductance of the first stage, because the current gain for the second stage is 1 here, nearly equal to the GM of M1. GM of M1. So this is the cascade amplifier. Question on BJT, question on FET, same answer you have to give. Next one. I think you are enjoying the session, guys, everyone. Now, this is on our BYJU'S exam prep app. You can give what? Test, right? When we are arranging the quizzes or mock test. Yes. And then finally you will get a leaderboard. Suppose there are participants 60 students. Then what is your performance? What is your score? What is your rank? Right? And each and everything will be here, okay, on this particular table. तो पूरा आपका जो है ना फीडबैक आपको मिल जाएगा. बट बिफोर दैट यू हैव टू इंस्टॉल द BYJU'S एग्जाम प्रेप ऐप फ्रॉम गूगल प्ले स्टोर. Okay, so you can download it now. Then guys, a link is given in description box. Now that is another question in 2002. 3 identical RC coupled transistors, amplifiers are cascaded. Means first transistor, second transistor, third transistor, we are cascading. Then if each of the amplifier has a frequency response as shown in the figure. Where is the frequency response? That is the frequency response. 20 Hertz, 1 kilohertz. The overall frequency response is as given in A, B, C or D. There are D options. That is given in 0 dB and that is the gain. It is down by the 3 dB, down by the 3 dB, down by the 3 dB. But what is the difference here? It is the difference in what? Frequency. Difference in the frequency. Lower cutoff frequency and higher cutoff frequency. There is a change in the lower cutoff frequency and higher cutoff frequency when we are comparing with the single stage. 20 kilohertz and 1 kilohertz. 40 kilohertz, 1 kilohertz and so on. 3 identical. Guys, if you have idea about this, remember when we are doing the multi-staging or cascading, first stage, second stage, third stage, this is called cascading, means output of one will become input for the other. First stage, second stage, third stage, all are identical. If all are identical, then what is the benefit of this? Gain bandwidth product increases. But what is the drawback of this? Bandwidth decreases. There is a shrinkage in the bandwidth. So what is the, if there are n stages, then lower cutoff frequency will increase. What is the new lower cutoff frequency? That is given by FL root over 2 to the power 1 by n minus 1. N is the number of stages. So there are 3 stages. And initially what is the lower cutoff frequency? 20 Hertz. It will increase. Where it is increases 40 Hertz, 40 Hertz, 40 Hertz. So no need to calculate because in every option it is 40 Hertz. You can, no need to calculate. Means definitely it will be 40 Hertz. Definitely it will be 40 Hertz. But you can find, this is the, what is the value given? 20 Hertz. Root over 2 to the power 1 by 3 minus 1, you can find nearly equal to 40 Hertz. Sorry, divide, not multiply, divide. lower cutoff frequency will increase. What is the higher cutoff frequency will decrease. FH asterisk is old FH multiplied by 2 to the power 1 by n minus 1. That is the formula. What is the n? 3. So you will get FH asterisk is equal to FH 1 kilohertz root over 2 to the power 1 by 3 minus 1. It will reduce. Check this value and tell me what is the value. So now there is a shrinkage in bandwidth. FL increases, FH decreases. There is a shrinkage in bandwidth. This is the new value of the FL. This is the new value of FH. Bandwidth reduces because of cascading. So which one is the less than 1 kilohertz? Only one answer is less than 1 kilohertz. It is a tricky question. No need to find the value. No need to find the value. No need to use the formula. 1 mark question. FL increases, FH decreases. Only this one. This answer is correct. Suppose the formula, then this is you can use this formula. Okay. Next. In a negative feedback amplifier using voltage series feedback. Using the voltage series feedback. Quickly give me the answer. In a negative feedback amplifier using voltage series feedback. Voltage series means what? At the output we are sampling the voltage, at the input we are mixing the voltage in a series connection. Then to both, when we are watch this diagram, at the output we are sampling the voltage, at the input we are mixing the voltage series feedback. So this is the shunt connection at the output. Shunt connection so that we can sample the voltage here. And series means we are mixing the voltage, and that mixing is in the series connection. This is VI. So VI will become VS minus VF. So that's why this basic amplifier is the voltage amplifier, and that is the beta VF upon V0, unitless quantity. Now, because we are connecting something parallel to the R0, and that's why ROF after feedback it is less than R0. Output resistance decreases because at the output parallel connection. At the input this is RI. It is in series. When we are connecting something in series, what about the input resistance? Increases after feedback. So increase in the input resistance, decrease in the output resistance. That is called voltage series feedback. So Ri increases, R0 decreases, C is the option. Input resistance increases, output resistance decreases. So there are 4 types of feedback: voltage series, voltage shunt, current series, current shunt. So I have given, please, this is called block diagram, and with the block diagram you can get the idea. No need to mug up, right? This is the block diagram. Okay, then voltage series feedback. So if you want the session on that, then you can suggest me on my Telegram channel in comments box, right? I will arrange the session for that. Next one. Now all complete feedback chapter, if you want, what is the voltage series feedback, voltage shunt feedback, then 741 type operational amplifier has a gain bandwidth product IC 741. This is the name of the operational amplifier chip. Gain bandwidth product of 1 megahertz. A non-inverting amplifier using this op-amp and having a voltage gain of 20 dB will exhibit a 3 dB bandwidth of. What is the 3 dB bandwidth? We have to find. Non-inverting amplifier, and what is the gain bandwidth product of op-amp? 1 megahertz. 1 mark question only. 50 kilohertz, 100 kilohertz, 1000 by 17 kilohertz, 1000 by 7.07 kilohertz. Then tell me which answer is correct. And the gain is 20 dB here. Will exhibit a 3 dB bandwidth of, and gain bandwidth product is given as 1 megahertz. Then remember, gain bandwidth product GBW is constant. and that is given as 1 megahertz, means what? 10 to the power 3 kilohertz. 1 megahertz means 10 to the power 3 kilohertz, 10 to the power 6 hertz. This is 1 megahertz. Okay. Now, what is the gain? 20 dB. So 20 log of AV is equal to 20 dB. So what is the gain? Closed loop gain. So 20 cancel, and what is the anti-log of that one? 10. This is nothing but closed loop gain for non-inverting operational amplifier. So with the help of feedback, we are reducing the gain up to 10. Remember, gain bandwidth product is constant and we are having the gain. So what is the bandwidth? Bandwidth is gain bandwidth product upon gain. 10 to the power 3 kilohertz upon 10. It will become 100 kilohertz. 100 kilohertz is the answer for this question, the bandwidth, gain bandwidth product. This is the answer. 100 kilohertz. Okay, this is very simple question. Now next one, in 2008 we have more questions from operational amplifier guys. In second part I will cover all the questions, important questions on rectifier, clipper, clamper, important questions from operational amplifier, because it is a common in what electronics and electrical. That's why I have to arrange what two part 1 and part 2. If you want the link of the part 2 PDF of this session, then join my Telegram channel so that you will get the notification, and subscribe the channel so that you are not going to miss this session. Consider the following circuit using an ideal op-amp. Where is the ideal op-amp? This is the ideal op-amp. The IV characteristics of the diode is described by I naught e raised to power V by eta Vt minus 1. Eta is 1 here, where Vt is 25 millivolt, I naught reverse saturation current 1 microampere. V is the voltage across the diode, positive for forward bias. For an input voltage minus 1 volt, the output voltage V naught is. What is the output voltage V naught? You have to find. Okay. Then, how we can find the output voltage V naught? Now watch this. First of all, you have to find the output voltage. Diode is not ideal. Current through the diode, it is given as I naught e raised to power drop across the diode upon Vt minus 1, and I naught is given as 1 microampere 25 millivolt. Okay. If suppose you want the V naught, then remember there is a negative feedback, and according to virtual short concept, Vp and Vn are 0. So virtual ground process, Vp is equal to Vn is equal to 0. This is called virtual ground process, right? It is a virtual ground process. Now from this point to this point, 4 kilo ohm diode, if the current will flow like this, so you can find the V naught because this voltage is 0. What is the drop across the 4 kilo ohm resistor and what is the drop across the diode? V. That will give you the V naught. So what is the V naught here? V naught is 4I. Remember, current should be in milliampere plus drop across the diode, Vd. Or that is nothing but V. That is the formula. So first of all, how we can say that diode is forward biased? Remember, what is the voltage applied here? Minus 1, and it is applied to what? Inverting terminal. And that's why if it is applied to inverting terminal, because of 180 degree phase shift, it is minus 1. Because of 180 degree phase shift, output will be positive, greater than 0. If the output is positive, try to understand, if the output is positive, definitely it will make the diode what? Forward bias. Definitely it will make the diode forward biased. Because of this -1, 180 degree phase shift, output is positive, diode is forward biased. And remember, this is 0. So what is the current? Current will flow in this direction. 0 minus of -1 upon 100 kilo ohm, then you can find the I. Same current will flow from this point to this point, because input resistance of op-amp is infinite. No current will enter into the operational amplifier. So what is the value of I? You can say 0 minus of -1 upon 100k. 100k, that is 0.01 milliampere. 0.01 milliampere, this is the current. Now, this is what 4 kilo ohm. This current will pass through this 4 kilo ohm. Now you got the 4I. But what is the value of the VD? The same current will pass through the diode. You got the value of I, you have the value of I naught, then you can find the value of V. V is the nothing but drop across the diode. Put in this equation. You will get 0.01. This is the milliampere. What is the I naught? 1 microampere. Remember, it is in milliampere. To convert it into micro, convert it into milliampere means 10 to the power -3 milliampere. 1 microampere means 10 to the power 3 milliampere. Convert it into milliampere. E raised to power V by Vt, 25 millivolt. And we want answer in what? Volt. You can put here in 0.05. That is in volt, -1. Now, 0.01 divided by 10 to the power -3. So that is nothing but it is multiplied with the 1000. You will get the 10 here. And this is +1. +1 is equal to e raised to power V by 0.025. Take the log of this. So this is what 10 plus 1, 11. It will become V is equal to 0.025 log of 11. Log of 11. Find this value. Log of 11. Now that is the drop across the diode VD. This is nothing but VD. And you have the value of the current. Add these two. Add these two and give me the answer. V naught is equal to 4I. 4 into 0.01, 4 kilo milliampere cancel 0.04 plus drop across the diode, you will get around 0.06. 0.06. So it is around 0.1. Which answer is correct? B option. B option is the correct. You are saying that it is a logarithmic amplifier. Yes, Amrita, you have given the, but my dear friend, there is a relation. What is the relation between the current and, yes, we are finding the e raised to power something. So if it is less than that, definitely it is a logarithmic amplifier, right? But what is the question asked here? Question asked here, V naught. So it is what drop across the diode as well as drop across what 4 kilo ohm resistor. You have to find the anti-log of that, then you can find, or you have to apply the log of this value. Ultimately this is the log 11. Okay, then next question. What is the value you have? You are using your calculator. What is the value here? Calculation is your part. You can do the calculation here. The next question. Okay. The operational amplifier circuit shown below represent a, tell me, what is this? High pass filter, low pass filter, band pass filter, band reject filter. Here if we are having the C, on the feedback path, if you are having the C, means it is a low pass filter. Or in the input we are having the inductor, then guys again watch this diagram, this one. For low frequency, for example, you can assume 0 frequency. What is the impedance because of the capacitor? 1 by omega C. That will become infinite. Means this capacitor will act as open circuit. You can remove this capacitor. And for 0 frequency, what about the inductor omega L? It will act as what? 0. Impedance because of the inductor is 0. Means inductor act as what? Short circuit. Inductor act as short circuit, capacitor act as open circuit, and we are getting the maximum gain exactly at 0 frequency. And what is the maximum gain? Minus R2 by R1. So what is the magnitude of gain? R2 by R1. This is the maximum. This is the maximum gain. Now, at t equal to infinite, at omega is equal to infinite, ZC will become 0. And ZL will become what? Infinite. Then what will happen? This same capacitor will act as short circuit. And when it will act as short circuit, this is short circuited to this one. And that's why we are getting the output 0. And this will act as what? Open circuit. So input will not pass. So exactly at t equal to infinite, what is the output? 0. So means at omega is equal to 0, we are getting what? Maximum gain. And at omega is equal to infinite, we are getting the minimum gain. It will pass the low frequency, but at the same time it will block what? High frequency. It is nothing but low pass filter. It is a low pass filter. You can also find the gain. What is the gain here? AV. That is nothing but minus ZF by Z1. Remember, what is the ZF? 1 by SC parallel with what? R. RF. That is connected in feedback path. This is C is parallel to R2. You can say R2. And what is the Z1? SL plus what? R1. Inductor and this resistor are connected in series. Then find the ZF by Z1. You will automatically get that it is a low pass filter. It is a low pass filter, guys. Okay. Then what is the band pass filter? Band pass filter is what? High pass filter followed by the low pass filter. High pass filter followed by the low pass filter. So normally what we are doing, high pass filter followed by the low pass filter, and the cutoff frequency for high pass filter should be lower than what? Cutoff frequency of low pass filter. F1 should be less than F2. F1 should be less than F2. Then we are having the standard circuit here. For example, this is the operational amplifier. So I have said now, I have suggested you, if you want the session on any topic, then please join my Telegram channel and give me comments. Then I will arrange the session for that. Okay. So this is the, when we are connecting the C here, this is called high pass filter. And this is what we are connecting the RC in parallel. This is a low pass filter. But what I have said, the cutoff frequency for low pass filter should be greater than cutoff frequency for what? High pass filter. Then it acts as what? Band pass filter. Band pass filter. So you have to check all this. Okay. Then we can say yes, it is a band pass filter. This type of filter. This is the high pass. That is the low pass. High pass followed by the low pass. Okay then. I think now it is clear now. It is a band pass filter. Then now I want to give some homework also, and next time I will, in next part I will solve this question. This is a very conceptual question, guys. Give one attempt, and then in my style I will give the answer for this question. I am solving the next 5 questions, but remember, this is a very important one. that first of all, because of this Zener diode output is limited, then find the voltage at this point. For positive value of 10 volt, for negative value of the 10 volt and limited output voltage. These are called the threshold voltages. Then what will happen if the switch is closed? Then what is the voltage across the capacitor? 0. Then this will become 10 volt. Suddenly you are going to open the switch. Always remember, capacitor does not allow sudden change of voltage. And that's why it will remain 10 and output will remain negative. Output will remain negative. And what is asked here? The time at t equal to t1 at which V0 changes its state. You have to find the time. This is a very conceptual question, guys. Right? Very conceptual question. So this is very important one. So this is a homework assignment for you. In next part, I will solve this question. Till then, please try to give me the answer in comments box or on my Telegram channel, that is Electronics by Sanjay Rathi. If you want to post your descriptive answer, yes, you can post so that I can check whether your approach is right or wrong and what is the mistake or what is the good thing about that. Right? Now, this is homework. Second, this question. Now guys, this is a question on what? Schmitt trigger circuit. This is a question on Schmitt trigger circuit. Consider the Schmitt trigger circuit shown below. A triangular wave which goes from -12 to +12 is applied to the inverting input of the op-amp. This is the inverting input of the op-amp. This is the Vi, where a triangular wave is connected. Assume that the output of the op-amp swings from +15 to -15. Swings from +15 to -15, that is the supply voltage. The voltage at the non-inverting input switches between. Non-inverting. You have to find the voltage at the non-inverting terminal. This is a question on Schmitt trigger circuit. Okay. Then how we can solve this question? Schmitt trigger circuit. Right. By different, watch the diagram. We are not getting the straightforward questions. There is some change in what rectifier, there is some change in what the diagram, there is some change in the diagram of what square wave generator and so on. So what is this? This is a Schmitt trigger circuit, but there is a positive feedback. Normally students are saying that, sir, we can apply the virtual short concept, but here we can't apply the virtual short because there is a positive feedback. What is the Vi triangular wave varying from +12 to -12? So what is the first answer? -12 to +12, but this is not the correct one. Why? Because we can't apply the virtual short concept. This is the triangular wave, vary from +12 to -12. Okay, then how we can find? Then remember, what is the range of the output from +15 to -15? At VB you can apply the KCL, and remember, current enter into the op-amp is 0. This is called non-inverting terminal voltage. So VB -15 upon 10, VB -15 upon 10 plus VB minus of -15 upon 10 plus VB minus V0 upon 10 is equal to 0. You can take 10 as a LCM. Then it will become VB -15 plus VB plus 15 plus VB minus V0 is equal to 0. Then this 15 cancel out. It will become 3 VB is equal to V0 because this 10 will become 0. So what is the VB? V0 by 3. Now since the operational amplifier have positive feedback, therefore there are two values only, plus Vset or minus Vset. So what is the plus Vset? 15. What is the minus Vset? -15. So what is the two values of VB? VB1 is equal to 15 by 3, that is the plus 5 volt. And VB2 is equal to -15 by 3, that is what? -5 volt. These are the two values. Okay, so that is over. Now -15 volt. So this is about the Schmitt trigger. Which question? This one. This is the answer, minus and plus 5. Minus and plus 5. C is the correct answer. For that is the question on Schmitt trigger. So I think when we are solving the last 3-year question paper 2002, 2008 and 2016. Almost all topics are covered here. Now next one. Guys, this is a question on what 555 timer. Now you can say, sir, that is not mentioned in the syllabus of that, but timer is mentioned, right? Somewhere timer is mentioned. So they can give the question, for example, in voltage regulator by using op-amp. For last 10 years, there was a limited questions. Then suddenly, for last 2 to 3 years, we are getting the question. Similarly, we can get, to get the basic idea about the timer, this is a very conceptual question. It is a astable multivibrator. It is actually a astable multivibrator. Okay, and then 30 kilo ohm, 10 kilo ohm threshold voltage is connected here. An astable multivibrator circuit using the IC 555 timer is shown below. Assume that the circuit is oscillating steadily, means under steady state. Voltage VC across the capacitor varies between. So normally what will happen, we are having the answer 3 to 6, VCC by 3 to 2 VCC by 3, but that is not the case. In this case, you will not get this answer. VCC by 3 to what? 2 VCC by 3. That is not the standard answer. This is a 2-mark question, guys. There is something different in normal from the normal connection. This pin, voltage across the capacitor, is not connected to the 2 and 6 simultaneously. Between 2 and 6, we are connecting one resistor 10 kilo ohm. Because of this resistor, there is a change. There is a change. So just I have given you the hint. Try to solve this question. It is a homework. You can upload the answer on my Telegram channel. In next part 2, I will solve this. I will solve this question. Again, we are getting the very simple question from the 555 timer, right? So what is the difference between the previous question and this question? I am going to solve this. Now, in this question, there is no resistance. This is the voltage across the capacitor is connected to pin number 2. Voltage across the capacitor is connected to pin number 6. That is the trigger and threshold. But in a previous question, there was a one resistor. When this is connected to the 2, this is connected to 6, then voltage across the capacitor, the range is what? VCC by 3 to what? 2 VCC by 3. And this is a standard circuit for astable multivibrator. In the astable multivibrator circuit shown, the frequency of oscillation at the output pin number 3. So we are getting the output from the pin number 3. And that's why it is of only 1-mark question in 2016. Same year, 2016. Directly you can apply the formula here. Right, this is the 2.2 kilo ohm, 4.7 kilo ohm. There is no diode. Right, then directly RA and RB it is given. So what is the frequency? I am giving you the standard formula for this. Is given by 1 by 0.69 RA plus 2 RB into C. RA 2.2 kilo ohm, RB 4.7 kilo ohm it is given, C 0.0022 microfarad it is given, and directly you can find the frequency from this formula. Okay, that is the about the 555 timer. Now we are having the number of questions, but in next session I will discuss. Remember, this is a national scholarship test. You can get up to 90% off on our program. Please note the date on 10th of September. Means after 2 days. Okay, 9 AM to 9 PM this Sunday. The window will be open for 12 hours. This is a golden opportunity for you. And then guys, Asu Jangda sir will take one important workshop for you on 13th of September at 7:30 PM. Ideal strategy to excel in GATE 2024. This is an interactive workshop. You can register now for this. Okay, so this is important one. Then this is again a next one question. This is again a homework. In next part I will solve this. We have number of questions guys. So in part 2 we will solve. This is a GATE 2024 crash course, a crash course for GATE EC aspirants, complete syllabus coverage. तो So you can join now for next 4 months, right? This is just a crash course. Within 4 months you will get the complete syllabus of GATE exam and you can start your preparation now. And with study material, live classes, recorded lectures, practice questions, and what mock test for electrical branch as well as for electronics branch, guys. Okay, you can join now here. And this is my Telegram channel, that is Electronics by Sanjay Rathi. Okay then, thank you very much for attending the session. You are on BYJU'S exam prep. Thank you.